Okay, so centers of triangles, you got them right there on your paper. They have some weird looking names, right? Circumcenter, incenter, and centroid. So we've got two that start with a C and one that starts with an I. So first of all, let's look at what we call the circumcenter. Okay, the circumcenter. Now let's look at the diagram first before we get into what's going on. So what we've got here is we've got our triangle and they've got these lines drawn. And what we can see is that these lines go from this middle point. They create right angles with each of the sides. And then they've got these little marks here on the sides. Does anybody remember what those little marks symbolize or what they mean? Okay. Not quite. Okay, not quite. Why do we need lines that, like, one line, two lines, and three lines? What's that supposed to represent? Okay, they have the same measure. So if they have the same little tick mark on them, then they have the same measure. So that means AX and XB have the same measure right there. BY and YC have the same measure. AZ and ZC have the same measure. Now they're all different from each other, but the ones that have the same tick marks are equal to each other. So these lines that are drawn here that we're looking at, XM, MY, and MZ, are what we call perpendicular bisectors. Perpendicular bisectors. Now this term makes sense, okay? Perpendicular, what does perpendicular mean? It forms a right angle, okay? Perpendicular forms a right angle. All of those segments there that I highlighted in purple form a right angle with the side. What does bisect mean? Anybody know what bisect means? Bisect means cut in half. You can bisect an angle, you can cut an angle in half, you can bisect a segment, cut that segment in half. So that's what we're looking at here. These lines, MX, MY, and MZ, are perpendicular to the sides of the triangle, and they cut the sides of the triangle in half. It cuts it into two congruent pieces there. So the circumcenter is the intersection right here of the perpendicular bisectors. Okay, the circumcenter is the intersection of the perpendicular bisectors. Okay, some important facts about the circumcenter. The circumcenter is equidistant from each vertex of the triangle. Okay, the circumcenter is equidistant from each vertex of the triangle. So that's what those other segments are there for. Okay, if we look at it, AM right here, this segment, CM and BM are all the same length. And they hopefully you can kind of see that they look like they're the same length there. Okay, AM equals BM, which equals CM. Okay, those all have the same length, and that's very, very bright. I apologize. Let me trace that in green so it shows up better. AM is equal to BM, which is equal to CM. Oops, too many humps in my M. All right, so circumcenter created by the perpendicular bisectors, the lines that are perpendicular to the sides and cut the sides in half. All right, let's look at the incenter. Okay, let's look at the incenter here. With the incenter, they've got lines here that have right angles, but what's creating the incenter is actually these lines right here. Okay, and look at what we've got on this one. We haven't marked the sides congruent. We've got angles here that are congruent to each other. So these have been created by the angle bisectors. Okay, this has been created by the angle bisectors. So this line right here, AM, cuts this angle here at A in half. Okay, this side of it is the same as this side of it. BM, that segment cuts the angle right here at B in half. CM, that segment cuts the angle at C in half. So where they intersect there in the middle at M is what we call the end center. Okay, the end center. The properties of the end center is that the end center is equidistant from each side of the triangle. Okay, it's equidistant from each side of the triangle. So in this case, XM is equal to YM, which is equal to ZM. Okay, XM is equal to YM, which is equal to ZM. The distance from the center to the side. That's always measured perpendicular there. So that's why those right angles are drawn in this one. Okay. So I'd mark my diagram. Put a little tick mark on these. Okay, put a little tick mark so you can see that those three sides have the same measure. We can go back and do that with the first one as well. Mark AM, BM, and CM. They have the same measure. All right, let's go over the last one, and then we'll talk about how you can kind of keep these separate, okay, how you can help remember what each of them is. Okay, the last one is the centroid. Okay, the last one is the centroid. It is created by these segments here are medians, okay, medians, and we'll write it here in these blanks. A median is created by a vertex connected to the midpoint of the opposite side. Okay? A median is created by a vertex connected to the midpoint of the opposite side. So if we start at A, the vertex of A, we draw this segment from A to Y. Y is right in the middle of that side over there. If we start at B, at the vertex, and we draw a line to Z, Z is right in the middle of that opposite side. Okay, and then if we start at C, we draw a line to X, that's right in the middle of side AB. Okay, so that's why there's those markings again. Those sides are cut in half because X, Y, and Z are right in the middle of each side. Okay, so the centroid is right there, that intersection of those three medians. There's a property here. I really don't think that they're going to make you apply it, but let me tell you about it. Notice all three of these lines right here are kind of split up, and they're split up proportionally. Okay, the longer side, so let's look at the line from B to Z. Okay, look at the line from B to Z. The part at the top, the bigger part, is 2 times that shorter part. Okay, the longer part up here at the top, BM, is 2 times as long as MZ. Okay, the same thing applies for CM. Okay, CM is the longer part of this line. It is 2 times XM. Or MX, however you want to name it. Okay. Same thing applies to AM. It is 2 times as long as MY. I think that it looks like it in the picture. Okay, it looks like it in the picture too, so that kind of helps. Now, the way that this standard is phrased is it says, verify experimentally the centers of triangles. So it doesn't tell you to apply any of the properties or anything like that. It's pretty much just wanting you to recognize them. So let's go back to the beginning and let me give you some hints for remembering which one is which, okay? Circumcenter is the longest name, okay? Circumcenter is the longest name. Perpendicular bisectors is the longest name, right? Perpendicular bisectors, angle bisectors, and medians. Circumcenter, perpendicular bisectors, the longest name goes with the longest name for what it's created by, okay? The in-center is the only one that starts with a vowel, okay? It starts with an I. Angle bisectors start with an A, and the vowels go together. In-center, angle bisectors. And then finally we have the centroid. It's the shortest one, and it's created by the shortest word, the medians. Okay, so really it's just a matter of, I think last year when we looked at the test, there was like one question on centers of triangles. So it's really just a matter of, do you remember which one's created by what? All right. So circumcenter is created by your perpendicular bisectors. In-center is created by your angle bisectors, and your centroid is created by your medians. Okay.